What's up, everyone? Today we are talking about colligative properties, and this applies to solutions. So, electrolytes are substances that dissolve and provide ions that conduct electricity. Okay, so you might see Gatorade, right? Has plenty of electrolytes. A strong electrolyte dissolves and produces many ions, whereas a weak one would only produce a few ions. Remember, we mentioned that ionic compounds, when dissolved in water, they conduct electricity. So salts are electrolytes. Okay, imagine this, Super Bowl Sunday, and you want to chill some root beers really quickly. How would you be able to do that? So how can we lower the temperature of our cooler here really quickly? We'll think about that and we'll get back to it. So that brings us to colligative properties. These are properties that change when you dissolve something or add a solute to your solution. This depends on the number of particles, not necessarily the identity of those solute particles. So what that means is something like NaCl versus KCl, they would have the same effect. And we'll get into that next. So, when you dissolve these particles, how many particles do we get? So, sodium chloride will break up into the sodium ion and chlorine ion. So that is 2 particles total. Okay? Calcium chloride would break into the calcium ion, and we would get 2 chlorines. So how many would that be? How many particles total there? We have 1 calcium and 2 chlorines. 3 total is correct. What about sucrose here? How many would that be? So 12 plus 22, 34, 45, you think? Nope, that's incorrect. So the correct answer is it's just 1. What? We have so many different parts though. So sucrose is the same as sugar, and sugar is not like an ionic compound. It's a covalent molecule. So when sugar dissolves, it's going to be a little different here. The sugar molecules actually stick together, as we can see here, instead of breaking up. So it just stays as one large sugar molecule. Okay. So there are a couple different properties that change when we dissolve something, a solute, into our solvent. We will see that the vapor pressure is lowered, and that'll cause the boiling point to increase, and it'll also cause the freezing point to lower. So we're going to talk about these 3 things. These are kind of the 3 main ideas for this lesson. So vapor pressure is lowered. So what's going on here? When you dissolve something, if you have a solute, it's going to block your solvent from reaching the surface here. In other words, basically adding a salt or a solute will make it more difficult to boil or vaporize a solution because you've got these extra particles on the surface blocking our liquid from escaping. Okay, remember, to vaporize something, the liquids escape as gas. Okay, and what that also does is that increases the boiling point. We need more energy. We have to increase the temperature more in order to vaporize or boil something that has a solute in it. Okay, so again, we said these extra solute particles are preventing our liquids from escaping as a gas. And so there's a real situation where you might think of this, and that's when you make pasta. So it says here, cooking pasta, where if you add salt to your water to season it, which everyone should do, then it'll actually take a little longer to boil your water. And the reason for that is because of this boiling point elevation, right? So it'll actually take longer to cook your pasta. So let's say you're in a rush to make a nice dinner for your boyfriend or girlfriend, or maybe for your family. When should you add the salt to the water if you're trying to get it to boil faster? Remember, we mentioned that adding salt would increase the boiling point. So what do you think here? Are you going to add it before or after? Okay, the last thing that it'll affect, the correct answer here is going to be you want to add it after the water has boiled. Okay, if you add it before, it might take a little longer because then you're increasing the boiling point, and yeah, it'll take longer for the water to get boiling. Lastly, we'll talk about freezing point depression. Basically, the freezing point is lowered when you add a solute to a solution because the solute blocks the solvent from reforming as a solid crystal, as you can see here. And so, back to our little situation here. Because you're lowering the freezing point, things get colder. So one way you can actually chill things really quickly is to add ice to a cooler. And so remember, the freezing point of water is usually 0 Celsius, but by adding ice, you're lowering the freezing point. So what that means is things will get colder. And if they get colder, then those root beers will hopefully be ready by the time your friends come over. If you ever have friends over. All right, so how do we get from this icy, dangerous road to this wonderful, beautiful road here? Well, it turns out ionic compounds are great as de-icers. And so how does this work? How does salt seemingly melt the ice? So remember, we mentioned the freezing point of water was, let's say it was 0 degrees Celsius. If we lower the freezing point, right, then now the water or the ice has to get colder in order to freeze. So it reverts back to its liquid form. So if the freezing point is lowered, then it has to get much, much colder in order for the water to actually freeze. So it reverts back to its liquid form. And that's a lot easier to drive on compared to the icy roads. Okay, so what do you think? In Texas, people were surrounded by ice. Which ionic compound do you think would work better as a de-icer? Sodium chloride, which has 2 particles, or calcium chloride? All right, so here's our answer here. De-icers often use calcium chloride, and so the reasoning for that is that calcium chloride produces 3 particles instead of 2. So basically, the calcium chloride has a greater effect because of more particles. So it has a greater effect on lowering the freezing point because more particles. So in summation, we talked about colligative properties, which includes lowering of vapor pressure, increasing of the boiling point, and the lowering of the freezing point. These effects depend on how many particles are dissolved. So the more particles, the greater the effect. So I'll ask you one last question here to compare and to summarize what you've learned. All right.